Welcome back. Here's our part 2 for natural logs. This part, the top portion, there's a few problems like this in your homework, but it's not something to be like freaked out about. Factoring with these, I think it's just more of a like, hey, when you see it, here's how we approach it. Yeah, think algebra 2 and probably algebra 1, depending on when you learned intense factoring. Probably, either way. It just depends on the curriculum. But this guy, natural log squared, is going to serve as like that initial x squared that you used to see all the time. Now it's just natural log squared. So if you think about it, we're going to factor like this. There we go. They're special, okay? Just give them a break. The first term is going to be that natural log x. There we go. The next term has to be two numbers that multiply to make 2, but that when added together make -3. So think about the factors of 2, 1 and 2. And in order for them to multiply together to make a positive, they both have to be the same sign. Well, that's kind of easy. If it's a -3 right here, they both need to be negative. -1, -2, make -3. So natural log -1, natural log -2. And there's your factoring. Yay! The crowd goes wild. This is a factoring that catches everybody off guard because they're thinking, oh my goodness, how do I set up 2 parentheses? Where does everything go? Am I missing something? Maybe, or you're just overthinking it. Factoring is always splitting things evenly into 2 groups or more, aka 2 groups. You could have 3 groups. That's a very interesting binomial triplet, I guess, something like that. Anyway, we're not getting that scary, hopefully. But if you look between these guys, between this first term and this second term, they actually have stuff in common that we can use. So like they both have factors of 4. 4 can go into both of these evenly, so we'll say that they both have 4 in common. They also both have natural logs in common, not just 1, but 2. This one's got 2, and there's 2 in there with 1 left over. So we're going to say natural log of 2x. When I take that out of both groups, what is left? When I take it out of this group, the 8 becomes a 2 because it factors. And when I take 2 of the natural logs out, 1 is left. All right, let's go to the second group. I'm going to put my little plus there because none of the signs change. When the 4 is taken out, I get a 1 because 4 divided by 4 is 1. And natural log of 2 divided by natural log of 2 is 1. So there we go. That is as factored as it's going to get. This one is probably even more rare than the 2 ahead of it, but still something that you're going to come across and you'll need to know for ACT, SAT. If you're going into math beyond this, you'll definitely want to know this one. All right. We will be splitting this into 2 parentheses, but not right away. Right away, we need to look at, first off, there's no way to split this so that we have a first term in both that make 3e squared, or that we have -2 and that factors of 2 that make 5. It's just not going to work. But here are some steps that you can do when you come across a situation like this. First, multiply a and c together. So that's going to be 3 times -2. We're going to get -6, all right? Next thing we need to do are finding factors of -6 that make +5. So the factors are 1, 6, 2, and 3. Now, -6 means that one of these columns is going to be negative. It's either, and this tells us which one. The bigger number will be positive, so the smaller numbers will be negative. With this, which group, when combined, makes +6? The first group. So here's what's going to happen. We're going to kind of go back in time and say, okay, if these two together made +5, then let's go back and make them what they originally were. So we're going to put, let's put +6 here, and let's put -1 here. 6 gets an EX, and -1 gets an EX, because how else would they combine together to make +5EX? All right, everybody else comes down. There we go. So I guess this would have been step 3, is plugging that in. Step 4 would be, okay, let's group them. Put a little plus in there because we're not actually multiplying them. And see what common factors are within each group. In this group, there's a 3 that's common, and there's an e to the x that's common. So we're going to pull that out. 3 e to the x. When we do that, this first term is just going to be left with an e to the x. And this second term is going to be left with a 2. Going to put our little plus there. This group, well, they don't really have much in common except a -1. If I take a -1 out of here, I get an e to the x. If I take a -1 out of here, I get a +2. That works for me, but now I want you to see this. The two groups are now officially, like this big group right here and this big group right here, both groups have something in common. They both have an EX plus 2 in common. So we're going to pull that out front from both of them. Whoosh, whoosh, right? When I take the EX plus 2 out of this group, I am left with the 3 e to the x. When I take e to the x plus 2 out of the second group, I'm left with a -1. And voila. That's our final factoring. The hardest, that probably would have been like our step, let's see, our step 4. I guess this would have been our step 5. Probably one of the most intricate, but it is solve worthy, and that's how you do it. Go back and relook at it if you missed some steps or you weren't sure, or give me a text if you're like, what just happened? All right, we're gonna move on to this next part, growth and decay. This is probably one of my favorites. I love growth and decay because, one, you're taking what's in front of you, you're plugging it into the problem, and then just like solving. You're either gonna solve by just like throwing it into your calculator, or doing like the natural log steps real quick to so that you can plug it into your calculator essentially. So let's do this. I know we did this first one in class, so we'll go ahead and work this one out pretty quick, and then I'll show you how B works. All right, the number of bacteria starts at 1,000. Oh, you know what? I apologize. We should come over here and look at this first. This exponential growth has quite a few things in it. This guy is the total. At the end of the day, you know, after everything has happened, what do you have left? This guy, notice I'm including the 0, is the starting point. So like when time is 0, what are you starting with? What is the amount of either money you have, bacteria you have, livestock you have? What is your starting amount? E is E. It'll always be E. So this is a number we plug in. It'll never change. R is the rate at which something is happening. Now it says % right here, but you are always going to want to change it to a decimal. Always, 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 always. And if you ever have to solve for the rate, you will find the decimal and then have to change it back to a %. And then, of course, there's T. T is time. Time can be seconds, minutes, hours, days, weeks, months, years. It does not matter what T is. The only thing that matters about T is that you stay consistent in the problem. So if at first it talks about T as in hours, and then later it asks for something with T as in days, you're going to have to make that conversion between the two of them. Either make hours become a percentage of the day, or take days and figure out how many hours you're dealing with. All right, here we go. Problem A. The number of bacteria starts at 1,000 and increases exponentially at a rate of 10%. How many bacteria will there be in 4 hours? Okay, now there is a second part to this problem. How long until the amount of bacteria reaches 10,000? We're not going to talk about that right now. We are strictly going to look at everything and part 1. Don't even look at part 2 yet. Just look at part 1. Part 1 says that we have a starting amount. So P sub 0 is 1,000. It says that we have a rate. That rate, even though it's 10%, move the decimal over twice, is actually 0.10 or 0.1, whichever one you prefer. And time. Time is in hours. So we have 4 hours that we're dealing with. Very cool. When I go to plug this in, it wants to know how many bacteria will be there in 4 hours. The one we don't know is the final. So that's what we're solving for. So we have P equals 10,000 E to the 0.10 times 4. And very cool. Notice that nothing on this side has a letter. As long as nothing has a letter, you can type that sucker into your calculator and get a final answer. I'll show you what that looks like. 1,000. Let's see here, E. If you have an E that has an exponent, perfect, because you're about to fill in that exponent. I'm just going to go ahead and type in, there we go, just the 0.1 times 4, and there we go. 14,900, wow, I have lost my marbles today. 1,491.82. Since this is bacteria, let's go ahead and round it to the nearest whole number. So this would be approximately 1,004, let's make that look like a 4 voltage, 490, we'll go ahead and round it to 92. So approximately that many bacteria after 4 hours. So that's about almost 500 more than what they started. That's a little scary. Well, that is if it's bad bacteria. If it's good bacteria, then it's good, clearly. Did you know there was such thing as good bacteria? You should. Hopefully you took Margaret Porch's biology class, so you know there's good bacteria and bad bacteria. All right, in part 2, how long until the amount of bacteria reaches 10,000? Okay, now what we're going to do is we're going to get rid of everything in part 1. We no longer have the 4 hours. Poof, gone, bye-bye. But don't forget, we still have the 1,000, we still have the 10%, and now we have this 10,000. So let's see what we have. Do we have P sub 0? We sure do. That's 10,000. Do we have the rate? We sure do. That's 0.1. Do we have the time? Nope, we got rid of that. But we do have the final amount, 10,000. All right, let's type it into our equation over here, and let's see how we can solve this. 10,000 to start, 1,000 E to the 0.1 T. All right, this is a problem. We can't just type this into our calculator because we have the exponent. You could, if you wanted, do natural log to both sides. I would recommend not doing that because if you'll notice, 1,000 and e are factors. So you'll have to use a lot more rules in order to solve it. Here's what I would say. Divide both sides by those big numbers first. So divide the 1,000 so that the e is by itself. Cancel out those zeros there, and we get a nice little 10 on this side. All right? So this is e to the 0.1t. There we go. And if you look back at the last page, when we came across something like this, we simply did natural log to both sides, and the exponent came out front. So let's bring this over here. Natural log of 10 equals 0.1t natural log of e. Natural log of e is just 1. 0.1t times 1 is just simply 0.1t. Natural log of 10, let's get t by itself. Whoops, that was special. 0.1, 0.1, and t is equal to whatever this is when you plug it into your calculator. What am I doing here? Oh, right, natural log. Natural log of 10 divided by 0.1. All right, we'll say that it's approximately 23 hours. So if it's not exact, you can always use this term right here, little swiggly equal sign. It means approximately, close to, not exactly 23. All right, part B, 1, 2, and 3. Let's get this going and call it a day. If a person opens a savings account with, this is now interest rate and compound interest. So where that was growth and decay, this is interest. If a person opens a savings account with $600 at a 3.16 rate, fixed rate, how much money will there be in the account after 10 years? This is our initial amount, P sub 0. This is our rate, which I would always rewrite 0.0316. Do not plug that in. That is a huge no-no. How much money will be in the account after 10 years? That's time. Notice what we are looking for, the final amount. This is going to be beautiful. P equals 600 e to the 0.0316 times 10. And you know what's beautiful? Is we just got to type that into our calculator because there are no letters over here. You just type that sucker in and you'll find that the final amount is approximately $822.98. You know, for money sitting around doing nothing, I know it was 10 years, but you gained quite a bit of money just for it sitting there doing literally nothing. What's the bottom line of this? You know, what's the meaning of this story? Invest your money. Smart. Like, not dumb, smart. All right, how much money will be in a person's account if they, that is definitely my typo error right there, if they invest $1,000 at a rate of 5% for 20 years? So again, we have an initial, we have a rate. I'm going to rewrite it because I want to. And we have time, so we don't have the final amount. Let's type it in. Final amount equals 1,000 e, don't forget the e, 0.05 times 20. From here, so just take that, plug it all in, and you get $2,718.28. Voila. Again, it is 20 years. I get it. But if it's just sitting there, you know you're not going to do anything with it. Just let it sit there. And not only did it make up another 1,000, but it was going on an additional 1,000. It almost tripled its initial amount. Just a thought, y'all. Okay, last one. Here we go. How long will it take in years for $1,000 to become 1,500 if it was at a 6.1% interest rate? I missed a word in there. If it. All right, so how long? So we have an initial, PO, P sub 0. We have a final, and we have a rate, 0.061. All right, so we don't have time. Let's do this. 1,500 equals 1,000 E, 0.061 T. All right, just like we did above, divide both sides by 1,000. E to the 0.061 T. There we go. So now we're dealing with smaller numbers. Very nice, very nice. But we are going to take natural log of both sides. Natural log, not log, because we are dealing with E. And it's just easier to fix everything when we put in natural log. Natural log, exponent goes in the front. So natural log of 1.5 equals 0.061 T. Natural log of E, that becomes 1. So with that out of the way, we're going to divide both sides by that number in front of T. And T becomes 6.7 years. Remember, they talked in years, so that's what your final is going to become. I know we didn't talk about rate, but notice that rate and time are in the exact same place. So if you're missing the rate and you have the time, solve it the exact same way. But when you get to your final answer, like R equals 0.035, because you're going to get something weird like that, take that decimal back 2 places so that you know what the percent is. Okay? All right, that's it from me, guys. See you either in class or in the next video.